Okay, we are only talking about one objective in section 6.3. 6.3 talks about another way of factoring trinomials when the leading coefficient is not 1. But we already discussed the method that we're going to use, the grouping method in section 6.4. But there is one concept we do need to cover in 6.3 regarding factoring perfect square trinomials. So as a reminder, remember that if you square a binomial, we talked about this in chapter 5, if you have a binomial that you square, such as x plus 5 quantity squared, what it really means is to square x plus 5, meaning x plus 5 times x plus 5. And remember, when you do that multiplication, if you FOIL it, remember what you get? You get x squared plus 5x plus 5x plus 25. And remember, whenever you square a binomial, you get two of the exact same thing, two of the same thing in the middle. So we get x squared plus 10x, right? Which is really 2 times 5x. Watch how I write it. 2 times 5x, which is really 10x, plus 25, right? So there is a pattern that always appears when you square a binomial. You always get, to square a binomial, you always get the square of the first term. In the case of x plus 5, that would be, the first term would be x. So you square the first one, which is x squared. Then you multiply the two terms inside the binomial together, x and 5, that's 5x. And then that times 2, which is 10x. That will be your middle term of your product. Then you square the last term, which is 5. And that's where we get x squared plus 10x plus 25. Well, if you remember how we multiplied those binomials squared and came up with the pattern for a perfect square trinomial, see, when you square a binomial, you get what's called a perfect square trinomial. Now, if I give you a perfect square trinomial, then you should be able to factor it into a binomial squared. So it's working backwards. So remember, and as it relates to the terms, your first term, for instance, in this example where I'm giving you the pattern a plus b squared, you square the first term, then you take 2 times the first term times the second term. That's a times b, 2 times that. Then you square the second term. But to go backwards, you look at your a squared, your 2ab, and your b squared, and you try to figure out what binomial must be squared in order to get that particular trinomial. So let's just go look at a few examples and attempt to factor them. Now, first of all, let's look at this and try to determine if it is a perfect square trinomial. So when you look at it, all of this you will be able to do it within a few seconds. Look at the first term and ask yourself, is it a square term? Yes, it is. And what has to be squared in order to give you an x squared? That would be x, right? Look at the last term. Is the last term a square term? Is 100 a square term? Yes. What has to be squared to give you 100? 10, right? So don't look at it as 100 and don't look at it as x. Start looking at it as x and 10. Now, the middle term has to be x times 10 times 2 if it's going to be a perfect square trinomial. Now, what is x times 10? Don't trip out on me now. Just tell me. It's 10x, right? X times 10 is 10x. And what's that times 2? We're trying to see if it fits the pattern. Times 2 would be 20x. Well, since the middle term is 20x, we know that this is a perfect square. And what would be the thing that we're going to square? X plus 10 squared is what it factors to. So it factors to x plus 10 times x plus 10. Now, if you wanted to look at this and factor it the old way that we normally do, you can do it. You can look at 100 and say, well, what two numbers multiply to 100 but add to 20? That's 10 and 10. And you would still get x plus 10 times x plus 10. I'm just saying that there are going to be times when it's going to be a lot easier for you to recognize that it's a perfect square trinomial and factor it that way. Look at the next one. Is this a perfect square? Well, is the first term a square term? Yes. What would it be if it, what do we square to make that x squared? X. Is the last term a perfect square term? Yes. 49 would be 7 squared. Is the middle term 7 times x times 2? 7 times x, yes, 7x times 2 is 14x. So since the middle term is that, then we apply that middle term's sign and say, okay, well, this is what we have, x plus 7 squared. Now, if that middle term was anything other than 14, it would not be a perfect square, and we couldn't factor it this way. Now let's look at this one. Is there anything that can be factored out of 4x squared plus 20xy plus 9y squared? Can anything be factored out? A GCF? No. Well, since we can't factor anything out, let's look at it and see. Is it a perfect square? Well, is the first term a perfect square term? Yeah. Well, what do you square to get 4x squared? That would be a 2x. What about the last term? Is it a perfect square? Yeah. But what do we square? That would be a 3y. Now, multiply 2x and 3y. That gives you 6xy. Is 6xy times 2 or 20xy? Is it? Is 6xy times 2 20xy? No, it's not. No, it's not. So guess what? We cannot factor this according to the perfect square. It's not a perfect square. So, you know, if we want to factor it, I'm going to have to scratch this stuff out. If we want to factor it, we have to factor it according to the methods that we've used before. And in this case, we have to use grouping. Okay? So remember, to group, you have to multiply, say, the 4 times 9. And what does that give you? That gives you 36. So we need two numbers that multiply to 36 but add to 20. That was going to be 18 and 2. So we take our trinomial, rewrite it. We have 4x squared plus 2x plus 18x plus 9. I'm sorry, I'm missing some variables. It's not 18x and 2x. it's 2xy and 18xy plus 9y squared. Alright, now we can go ahead and group those. You can't forget this. And we factor out a 2x, and it leaves us 2x plus y. And over here we can factor out a 9y, and we have a 2x plus y. And all together, when we factor out the 2x plus y, we have 2x plus y times 2x plus 9y. So you see, it's not a perfect square because it doesn't end up being the same thing inside of our we don't end up with the same binomials. So this is the factored form, and it's not a perfect square. Let's look at the next one. Is it a perfect square? Well, you should be able to see very early on that it's not a perfect square because, number one, 7 is not a perfect number, perfect square number. So we can't do this one as a perfect square. So we have to use factoring by grouping. Okay, so let's see. 9 times 7, that's a 63. I need two numbers that multiply to 63 but add to 24. That's 21 and 3. So let's rewrite the polynomial with 4 terms now. 9r squared. I'm going to put the 3rs plus 21rs plus 7s squared. Remember, the middle terms have to have rs. Now we can group them. Factor out a 3r, and we're left with 3r plus s. Then factor out a 7s, and we have 3r plus s. And factor out 3r plus s, and we have 3r plus 7s. So it's not a perfect square. We had to go through the process of factoring in this case. Let's try another one. Excuse me. Is this one a perfect square? Can anything be factored out? Well, 36 is a square term. N to the 4th is a square term. And 1 is a square term. Now, what do we square in order to get 36n to the 4th? That would be 6n squared. What do we square to get a 1? Well, that would be 1. Now, is the middle term 6n squared times 1 times 2? Remember, it's always times 2, which is 12n squared. Yes, it is. So guess what? We can take 6n squared minus 1 and square it, and that will be our factored form. Okay? Look at the next one. You can always go through the long way and do it if you want, but it will save time if you recognize it. Is this one a perfect square? 25x to the 4th minus 20x squared plus 4. What is 25x to the 4th? What do we have to square to get that? That would be a 5x squared. What about 4? What did we square to get 4? That would be a 2. Is the middle term 5x squared times 2 times 2? So that would be 10x squared times 2 is 20x squared. Yes, it is. So we factor it to 5x squared minus 2. All of that raised to the 2nd power. And there we have it. Now look at this one. Factor 12x cubed minus 84x squared plus 147x. Now here you got to be careful because there's a GCF that can be factored out. What's the greatest common factor here? Think about it. You might have to do a little work to figure it out. But I'm going to tell you, it is 3x is the GCF. And once you factor out the GCF, you have 4x squared minus, what's 20? I think this is 28. 84 divided by 3 is 28x plus, and then 147 divided by 3 is 49. 49, not 49x. 49. Now we have the 3x, but now the trinomial looks like it may be a perfect square, because 4x squared is a square term, 49 is a square term. But you have to look at 49x squared as 2x, because that's what you square to get it. You know, it looks like 2x. And 49 would be 7. Well, is the middle term 2x times 7? That's 14x times 2. 28x? Well, yeah, there we go. But it's negative 28. We square it, and then we multiply it by 3x. And there we have it, the factored form. With 8n squared minus 4n plus 50, you can factor out a what? I think a 2. 2 is the biggest thing that can come out, so let's take out a 2. And then we have 4n squared minus 20n plus 25. Now, is that trinomial a perfect square? Well, 4n squared is perfect square. I have to look at that like a 2n. 25 is a perfect square. I have to look at that as a 5. Now, is the middle term 2n times 5 times another 2? Yes, it is. And it's negative because the 20n is negative. Squared all times 2. And we have just factored these perfect square trinomials. Now go back and work your problems, and we're going to next talk about factoring binomials. Good luck.